In this session, we are going to look at the proof of the power rule, which says that if the function f at x, which is equal to x exponent n, where n is any number, then the first derivative with respect to s is given as nx exponent n minus 1. We are going to prove this rule using the first principle. So we know that in using the first principle, we first have to write our f at x and then write our f at x plus h. So we have f at x is equal to x exponent n, and then our f at x plus h is equal to x plus h exponent n. And then after that, we substitute this back into the first principle formula. So we are going to get the first derivative with respect to x, which is given as the limit as h approaches 0. We know that f at x is equal to this, so we have x exponent x plus h exponent n minus f at x, which is what? X exponent n all over h. The next thing we are going to do is to expand this. Now, to expand this, we are going to use what? The binomial theorem to help us expand this part. So in doing so, we are going to get the limit as h approaches 0. In expanding this using the binomial theorem, we are going to get x exponent n plus nx n minus 1 h plus n bracket n minus 1 x n minus 2 h squared plus, let's write the last two terms, which is nx h n minus 1 plus hn, and then we have minus our xn all over h. Let's remove the bracket and see what we are coming out with. So we have the limit as h approaches 0 of x exponent n plus nx exponent n minus 1 h plus n minus 1 x exponent n minus 2 h2 all over 2 factorial plus nx h n minus 1 plus h exponent n minus xn all over h. So from here we can see that minus n xn and then positive sn will go away. Now we are left with the limit as h approaches 0. Let's bring the h in front so that we have something like this, and then bracket n x exponent n minus 1 h plus n minus 1 x exponent n minus 2 h2 all over 2 factorial plus nx h n minus 1 plus h exponent n. From here, when we take the limit as h approaches 0, we are going to get 0. So what we are going to do is we are going to factor h out because we have h, and h. So we can factorize h out. So we are going to get the limit as h approaches 0 of 1 over h, and then times, we are factorizing this h out. So we are left with n x n minus 1 plus n minus 1 x n minus 2. We factored 1 h out, so we are left with 1 here, plus n x h, we have factor 1 h out, we are going to get n minus 2 plus so we can see that this h and this h will go. Now we are left with the limit as h approaches 0 of n x n minus 1 plus the limit as h approaches 0 of n minus 1 x n minus 2 h plus n x h n minus 2, the limit, we are taking the limit, plus the limit as h approaches 0 of h n minus 1. So when we take the limit here, we are going to get n x n minus 1, and this is going to give us n minus 1 x exponent n minus 2, the h is 0, plus taking the limit here, we are going to get n x h exponent n minus 2 plus h exponent n minus 1. So the whole of this will give us n x n minus 1. We are getting 0 plus 0 plus 0, and at the end we are getting n x n minus 1, and this is what the power rule is saying. Thanks for watching.